Hello, everyone, and thank you very much for coming this evening in August to see David here talking about data visualization. Well, this talk is organized by Hackademy, and for those of you that don't know about it, I just give you a brief explanation. We organize training for developers based on working on open source projects in collaboration with startups. And on the other hand, we find technical talent for startups also. And within the current edition, we had a lot of interest in data visualization. And we couldn't think of a better person to give an introduction to the topic and to talk about the design and some tools about data visualization than David. It's coming from social noise, and he has expertise in the field and give for sure extraordinary introduction to the topic. So thank you very much, David, for coming, and here is the floor for you.
Thank you. Okay, let's get started. It's been a challenge for me here to condense the whole topic of data visualization in 1 hour and a half. I don't know even the different profiles here, if you're coming from technical fields or maybe graphic designs. But I try to focus in 6 big parts of content, and I think I cover all of the different fields the data visualization has in the basis. Not the basics, but the basis. It's been a while since my last lecture in English, so please be kind. And if you don't understand something, I rewind and explain it again. And there is a lot of content here, so I'm gonna go not very fast, but fast. And if you have questions, just stop me, but be wise too, because there is a lot of content here. There's also a lot of links and resources, so after the lecture, you can review this presentation and go deeper, for example, in D3 and some technologies and some examples for that. So I'm the Innovation Director of Social Noise. It's a digital creative agency here in Madrid. We're focused on marketing campaigns with a big presence of technology. I used to be the CTO for the first 4 years in the company, and 2 years ago I created a new department. We call it Innovation because it's marketing, but it's mostly a product design and development department. So we develop our own digital products, mainly database and data-driven products. So for the past 2 years, I've been learning and mastering my knowledge about data visualization and work closely with teams. So I've came up with this presentation that it was the content that I wished someone had told me 2 years ago. So I hope you enjoy. So data visualization. To break the ice, I just select this beautiful visualization. It's based on the color names. You have a common area right here with women and men. And you have colors like green, purple, blue, things like that. If you go lower to the bottom part of the graph, there are only names called by men. For example, skin, a very certain determining color, name for a color, or for example, peace yellow. So it's mainly name for a color. And if you go up, you see only color with a percentage used by women. They're more exotic and more certain, more determined for colors. For example, coral, or for example, Mediterranean blue. So this data visualization, you have a lot of data in the back of it. It's also an interactive visualization. So if you get a chance to get this presentation, you can click on it and go ahead and play around with it. And but data visualization is a wide field, and the definition isn't clear. So I'm going to do a little test for that. I'm going to ask you which of these graphic representations do you think it could be called data visualization. So raise your hand if you think this one right here should be a data visualization. Yeah, more or less, 50%, more or less, okay. What about this one? This one is very cool. It's from a book called Coolness Graph. It's all about graph labeled by very cool and uncool and very stupid topics on it. So it's very fun. So what do you think? This should be a data visualization. We should call it data visualization. Yeah, a little bit less. Okay, 30%. Okay. This one is a scientific representation of the brain activity in 3 cases. You have a healthy person, a brain damaged person, and a vegetative stage person. So what do you think? We should call it, we're visualizing data, but in this case, we should call it data visualization? Yeah, okay. Well, 60, 70%, okay. This one right here, this is a timeline. Is the genealogy of pop rock music. You have a ton of music groups that were relevant in the past, in the history of pop rock music. You have names, and you have here years where the groups started. So we should call it data visualization too. Well, 90%, more or less. Okay. This one right here, I recommend this book. It's the best American infographics. It's launched every year, and it has a lot of cool infographics, very cool selection for that. Right here we have month, dates, and the darker colors reflect the most common dates to be born. So data visualization? Yeah, 100%, okay. And the last one, this is from Aaron Koblin. He's a digital creative artist, data scientist, programmer, whatever. He's been done some cool stuff. And in this case, you have air traffic over North America. So he took all the planes with their trajectories, and he drew it in a beautiful infographic video. So data visualization? Okay. 80%, perfect. So it isn't really clear. We've seen some examples of information visualization. It's not all the information that we've seen before is not database information. For example, we can see photograph, we can see flowcharts, we can see traffic symbols. We are visualizing information, but not all of that is database information. So around the information visualization, we have data visualization. Some people say that you have to visualize raw data, only raw data, to be considered data visualization. But I think this is a mistake, because when you get dirty with a project, you have to redefine the data, clean it, play around with it, so it is never raw data. This is another visualization. We have information graphics, that we call it infographics, and many of the infographics are made by information, not data, but there is a common place between data visualization and infographics, so you can mix them around too. This is an infographic. You have right here years, and you have different items that were located in this year, so it's not the big difference between data visualization and infographics is this one. Infographics is mainly subjective and is made to communicate something, not to explore or to learn anything. It's just communication, and it's always design-centered. So the important thing here is to communicate something, not the data behind it. So the previous example is an infographics that has just a little bit area in common with data visualization. So you can find another beautiful and good examples that doesn't fit quite right. So right here we have the Walking Dead comic books, and somebody spent time counting the death in each issue. So killed by zombies and killed by men, and you have like drops of blood, and each length corresponds to data of killing in the series. So if we take seriously that data visualization is only for exploring, what is this? This is mainly data visualization because it's almost data and just a simple graphic. So data visualization have another purposes. For example, in this case, just have fun, just something to admire. This is a cool one too. Is from Best American Infographics, and we have right here pie charts, and in all of them we have 5 divisions with the colors more used with each artist in different years. So you can see the evolution of one artist, or the evolution, the different color palettes of each artist during 1 year. You can use it to explore, but it's mostly to have fun, to understand something in a different way, things like that. This is the definition of the Wikipedia. It's not official definition, but most people just look data visualization and got into this point. And in Wikipedia, you can see the goal of data visualization is to communicate information clearly and efficiently to users with statistical graphics, plots, informations, and helps users to analyze and reasoning about data and evidence. This is a problem right here because it's a very close definition in the objective and in the items you have to use to visualize data. And for example, things like this is a company called DNA 11. You give them a sample of your DNA or saliva, and they draw these beautiful frames with that. So they are visualizing data, and it doesn't fit in the previous definition. So I came up with taking one thing from one place and one thing from another with this definition. It's a wider one, but I think it fits right. Data visualization is a mix of many disciplines whose goal is to communicate database information in a visual way with a certain objective and a certain target audience. What does this mean? We have many disciplines going on right here. You have computer science, you have math, you have statistics, you have graphic design. You can visualize it in different ways, not just an image or a video. You can use mobile application, interactive app. You can use it, I don't know, whatever you think. It have to have an objective, but it not always is the same. In some definitions, data visualization is only to explore, but I think this is wrong. You can use it to inform. For example, a commercial video that uses infographics for that. You can use it to explore. You can see, for example, the data journalism to do that, or you can use it just for admiring and have fun for that. And you have to focus on your target audience. You could focus on a mainstream audience and in company meetings, things like that. So this is a wider definition, but if you fill in the gaps right here, you get a definition right in each project. So that's the definition of data visualization. Everything right till here? Okay, yeah. Okay, the why. What is important? Why data visualization is a buzzword right here? The main thing is we are generating tons amount of data, and it's going really fast, and it's going beyond technology, and there are a lot of formats, and we don't want just to store this information, but to process it and get intelligence from it, and we want to visualize it to the target audience correctly. So this is a huge thing going on here. And the other thing is that we are a visual species. So we are mainly visual. All of more than 60% of our external impulses come from our eyes. So it's very important to visualize correctly the data in order to communicate to someone. So data visualization, it can be used to many purposes, but right here I have the 3 main purposes. It can use to explore, as we're going to see right now some examples, inform and admire. And you cannot, you don't have to use one of them each time. The rich application is to cross them around. There were 2 big moments in the history of data visualization. The first one is cartography. Is the first one. This is a fragment of the first world map. I think it's from 1824, I think. And it was used to explore. It was just a canvas when you have nodes and places and geolocations, and you have a ton of them, and you you can play around with it to explore. If you go far, you can use, for example, Google Maps not only to explore, but to inform. You can, for example, detect the shortest route from 2 places. If you go one step ahead, you can use data visualization in maps to admire. For example, in this case, CartoDB is using the Twitter reaction in a match between Real Madrid and Atletico Madrid. So you can use it to explore, to inform, but also to admire. It's a beautiful visualization. And the second biggest step in data visualization is the observation of our world. Not our world, but the universe. In this case, this is the first time series, is from the 10th century, and it shows the movement of the different stars and planets, and it was just do it to explore, just to keep track of them and see what data, what knowledge I can get from that. If you go one step ahead, you can have, for example, tide tables. You can use it to see if the sea, the level of the sea is high or is low, so you can go surfing or fishing or whatever. So this is a visualization. You have the hours, you have the level of the sea, and you get a tide table. So you can use it to inform based on the data you have. And finally, you can create beautiful, most advanced visualizations. This one, it wants to compare Earth to the sun and then to the 3 biggest stars in the universe. I can do it in a very static way, but here you have, for example, the temperature, you have the diameter, you have the name of the star, and you have the radius. So right here is Earth, and right here is the sun. And you're going to see the 3rd star right now, and you're going to freak out. So this is a very cool way to show it. Based on the information, you can show it to or communicate it to people in different ways, and this is an awesome way to do it. Besides the 3 main purposes, you have other. You can even invent the purposes of data visualization. In this case, this was one of the first data visualization used to solve a problem. It was done by Dr. Snow. In fact, his name was Jon Snow. I don't know. And this visualization right here is the map of London. They have a huge problem with cholera. And Dr. Snow, what he did is draw little black points in the streets and places where the people die. He found out 2 things, two very interesting things. The first one is no one from the beer factory died. That was strange. And the second thing is all of the biggest groups of dots were around water fountains. So he came up that the cholera was spreading by water fountains, and he asked what happened with the beer factory. And, well, they have free beer, so they didn't drink water. So he came up with a solution for that. Another thing you can use data visualization is to communicate something better, to get a better understanding for that. I can show you these big numbers right here, and you get a sense of how much it is. But if I use some different measures that we understand better, for example, video games market is not the same. Well, internet porn industry is higher than the cost of feeding every child in the world for a year. So this is something that we understand. And we can paint it with a 3 map, and we can play around with the areas to see which thing is better. Which thing is bigger, and you can understand it better. And finally, another purpose is to detect pattern, is to do some research. What do you think this graph is about? We have one peak right here around March, summer, and one peak right here around November. The what? The rain. Could be, but not. It could be too, but not. Okay. It's a peak of breakups according to Facebook status. So the people break up more after the spring or during the spring break. This is an American infographic. And just before the Christmas holidays. And of course, the lowest point in the graph is Christmas. It's too cruel to leave someone in Christmas. So that's the definition, that's the why, and we're going to talk about the process. There is a very famous data designer. It's called Alberto Cairo. He wrote a book, an amazing book. In fact, it was the first book I read about data visualization. It's called The Functional Art. He was the responsible, I think, during 2000, 2005, of all the infographics in, I think it was El Mundo, here in Spain. And then he went to Miami to give lectures about data visualization. And he created a little studio and do wonderful stuff. So in the book and in his page, he tells us what is his process of data visualization. You have to imagine you have the data, process it, clean it, wonderful just to play around with visualization. So he had a challenge. He knew, because he saw in the data that in the US, obesity was inversely proportional to the education of the population in each state. So the states with a higher education have lower obese people in their states. What he wants to do is to communicate this in a very easy and effective way. So he started to play around with this visualization. He geolocalized the states and the data and just draw a circle for that. In this case, this doesn't mean anything. He played around with a second value, in this case, the color and the brightness. And you can see right here, there are places, for example, I don't know, Florida, that you have almost the middle part, and right here you have, I don't know, it's the middle or it's lower. It's very complicated for an eye to see the difference between this palette and this palette right here. So he played around some more. He ordered the information of the states higher to lower in the bachelor's degree, and he did the same thing with the percentage of obese people. Something came up. You can see here the top 10 states are just right here with the top bottom. You can see Colorado is just at the end. You can see District of Columbia is right here. In fact, he played around some more, and he saw this beautiful graph where you can see that the lower states, the state with lower percentage of obese people had the highest percentage of the people with higher education. So finally, he came up with the final visualization. It's the cover of the book, and it's one of the famous visualization. It's called as a scatter plot with continuous lines, and it's very beautiful, and you can understand this inverse proportion with education and obesity. So he left us with three tips. The first one, accept that graphic is a tool for understanding. So he played around with graphic just to get to the final. He didn't just sit around and think with the final visualization. He just played around with that, and that's a big tip. The second one is be curious and start making simple graphics about topics you care about. Just play around and do it whatever you want in a notebook. In fact, there is a discipline. It's called visual design. It's not design thinking. It's visual thinking. It's how you communicate things in a visual way, complex concepts. So you can do that with graphics too, with data visualizations. And the last one is educate yourself in creating hierarchies, narratives, stories, because as you're going to see in the fifth block of content, it's all about storytelling. So data visualization at the end is representing something visually, refine it. It's an iterative process, and then you can give some interactions to it, think about how the user is going to move around with that. But this is only a small part of a huge process. this process right here, from acquiring the data, parsing it, we have the exploratory data analysis where you mine the data, play around with it, you clean it, you see if you have correlations, and you give it perfectly to the next part, so it can be visualized. It's a very long process, and you have different people, expert in different fields, to go all the way around. But I think this kind of process is called a T-shape process, or it needs people with a T-shaped talent. What does this mean? You need to have a deep knowledge in something, in this case in data visualization, in the last part, but you have to know what is the process and understand the technologies around it, and even work closely with teams for that. So if we zoom in the T, you have right here a lot of technologies, tools like Storm, Sparks, Python, MySQL, Hadoop, things like that. You don't have to be an expert on them, but you have to know at least what you can do with them. And if you are not managing, but working closely with a team, you have to, even if your part is the last to visualize the data, it's very rich to be in the process, in the whole process for that. And in the case of data visualization, I think it's all about communication and storytelling at first. You also needs to have knowledge about graphing design or playing with tools, visual tools like Tableau, for example, as we're going to see. And if you can reach to know some technologies, about simple technologies, for example, HTML5, GS, and if you get to D3, it would be wonderful. I'm going to give some example of D3. But playing around with that, it could give you tools just to get to the final visualization. Because if you play around, for example, with Tableau, it's like playing with Excel. You have a top line for that. If you are playing with D3, you are creating your canvas for that. So it's very interesting. This is a very cool infographics. This is a path, the data scientist path. So this is crazy. What I think, if you want to be a data designer, or you have to work with data designers, you have to understand perfectly this part right here, be an expert on this one, and understand things around. You have from fundamentals of math and statistics to programming, I know, a lot of things. So be a master on this one, and know the rest, so you can enrich the process. I really love this book, Data Plus Design. It's an open source and free book. You can download it through the internet. And it reviews the whole process in a very simple way. In fact, they change the names to collecting data, preparing data, and visualizing data. And they compare this process to the cooking process. So it's very interesting, because there are some very hard concepts that right here are very easy to understand. So the thing is, you have to imagine you are in a kitchen, beautiful kitchen. You have the perfect ingredients. You have, I don't know, data science, statistical guy who prepared these data ingredients. They cut it and they leave it just for you to play around, and you have to cook. So this is the premise of the book. And well, even if you invest time in helping the people that buy the ingredients or preparing them, in fact, the data visualization work is to cook. But before we cook, we have to clear, or to have in mind 5 big things. The first one is you have to have a great story. Maybe you don't have it at first, but you need to have an idea. In fact, in the process of visualizing data, there is a story finding process, but you have to have the seed idea before you start visualizing. You also have you need a message. In the case of Alberto Cairo, he just wanted to show the correlation between obesity and education. That was his message. And then he thought of his audience. So he can visualize it in a very, I don't know, kid way. You can visualize it to, for example, a board members of a company, or you can do it for the mainstream public. So you have to know your audience. or even you have to know your content to be sure that it's the perfect content, and then respect your audience to say, hey, this is the perfect content for everyone. You can do it that too. And at the end, you have to decide which data you want to illustrate, and of course, decide how to illustrate. And this is the 5 things of the process. And then you have to sit around and play with that. You're not going to do it right at first, but this previous thinking will lead you in a faster way to the perfect solution. Everything fine? Understandable? Yes? Okay, definition, the why, the process. We're going to talk about the basics. So I'm ready to visualize data. So what are the basics, the Lego pieces of data visualization? We're going to talk about three things. We're going to talk about data types, visual encodings, and chart types. There are a lot of types of data, but if you see closely, you can play around with these 4 big blocks or fields of data. You have ordered data you can compare, okay? And you can, in this line, you can have discrete data, for example, things that are not continuous. You have certain values. For example, you have ordinal values, for example, the size of a t-shirt. You have S, M, L, certain values, and you can compare them. Or quantitative data. You have, for example, numbers 1 to 5. You can compare them, and it's discrete values. And you can go to fields. These are continuous values. For example, temperature. In temperature, you have infinite values between the 2 values in your scale. So this is continuous, but you can compare this data. So this is a huge amount of data types right here. You have another data, for example, geo, the names of the countries, for example, Spain, France. You cannot compare the names of the country. You can compare some attributes that will fit in right here, but not the names. But there are data or information you are visualizing in a data visualization. But these are discrete. And you can have continuous values, for example, directions, latitude and longitude, and you have a wide range of numbers between them. In fact, it's an infinitive numbers between them. With these data types, you have to select visual encodings. Visual encodings is the group that take care of all the ways you can visualize data. You can play with position, length, angle, area, and not always, not for example, position and area, it doesn't work the same way with our brain. It's simple for us to see different differences between 2-bar graph than, for example, 2 circles, as we're going to see right now. How many times do you think the right circle is bigger than the left one? 5 times? 6 times? 6 times? 7 times? 8 times? 9 times? More or less? 9 times? More? 10 times? 10 times, okay. What about this one? How many times bigger the rectangle from the square? 5 times? 6 times? 7 times? That's right. In both cases, it's 7 times. So it's really easy for us to just play around with it and just compare with this one. And this one is very hard to play around with it. So for more accurate values, you can use bar graph in and not area. You can use area if you want to visualize very different data, as we're going to see right now. So we have a ranking of visual encodings. We have position at first, or length, and at the bottom we have area, volume, and everything about color. In fact, for us, it's very we can different 2 colors. We can different the hue of the color. But for example, the saturation, the brightness, the density is getting hard for us. So this is a very useful tool to select the different attributes you can play with a data visualization. To be in the same page, these are the different attributes of color. You have the hue. You have the hue right here, is the color. You have the saturation, is the space between the hue and the gray scale. The brightness is the difference between the color and the black. And densities is all about opacity, is playing with opacity or giving a solid color for that. There is not a written rule to play with color in data visualization, but just to use the less color you could possibly use. So it's recommended to have only in between 5 and 10 hues, solid colors. And if you need more, because for example you have 12 variables, so each one must have a different color, you can play with 6 to 6. These are not pure 12 colors. You're playing with 6 and 6 variation of that. And you don't have to forget white, black, and gray. These also are colors and are very important. In fact, when we visualize data in our projects, we visualize it in gray scales, and then we apply color for that. We try to find the perfect representation and then apply color. The same thing happens with saturation and contrast. You cannot use saturated colors for example, big fields. For example, the fields inside a bar graph. You need to use it with points, strokes, symbols, things like that. Very, very tiny things. And you need to use the saturated color for that. In fact, you can play around desaturating colors to, for example, have a blue palette, and you desaturate this color and use it the same color but with different brightness. Well, you have to use many different brightness so you can see the difference between one another. But this is a very common mistake to use, for example, bright colors inside a bar graph. And then you have to play around with contrast, not just for text but also for graph to see perfectly the graph that we are visualizing. So, for example, what's the problem with this graph? What do you think? Or is perfectly done? Okay, that's one problem. You are using a palette of blue, and you are not playing right with the contrast and the brightness. Okay, that's one. Another one? That's right. It seems that we have, I don't know, click, or we want to highlight this line right here because it's different from the other one. If we don't want to highlight this, is another data of the graph, we must use the same palette for that. So that was the big mistake here. And this one is a curious mistake because we, in the ranking of visual encodings, we see that shape is more accurate than color. But in this case, it's harder for us to see the red circle, and right here is very easy for that. So we have to apply some common sense. We can use a lot of tools and guides to select the different chart types and visual encodings, but we need to apply common sense for that. If we want to innovate in data visualization, we have to do it this way. And two more things, fonts. This is crazy. In fact, the fonts we must use in data visualization must be sensitive without all these arrangements around the fonts. So Helvetica, Arial, Hill Sans will work just fine. The same happens with the icons. We must use icons that are a visual metaphor that what we want to say. For example, if we want to say a person or test subjects, we must use an icon of a person. We can use I don't know, an icon of a dog, but that doesn't make sense. This is very easy to understand, and it must be measured. In this case, it's the same information, but right here, if I take this legend, if I tell you how many people we prefer call, it's very hard to get this information, and right here, you're just counting persons. So the icons must be easy to understand, the icon per se, and the measure. So visual encodings and data types. What happens if we mix these two? We get, and we have a relationship between visual encodings and data types. We have chart types. Chart types are the smallest visual representations in data visualization. In fact, sentences are to speech what charts are to visual encodings. I'm not going to overview all of them because it could be hours for that. I'm going to review just a few of them and give you a cheat sheet, a very special tool that if it's like a flow chart. If you select what the path you want to do, for example, comparison two variables, it will give you the perfect chart type for that. So you don't have to think. But this is important because in these slides, I'm specifying what data types must be compared in each graph. In this case, for example, we have independent variables. For example, I don't know, soccer teams. And we have right here dependent variables because there are variables that depend on the team and across each other. For example, the number of Champions Leagues won by each soccer team. In the case of line chart, we're playing with the same, but it should be continuous. So the soccer team example, it doesn't fit right here. You have to play with, for example, evolution. What is the evolution of the followers in a Twitter account? So you have right here independent variables, the days or the month, and you have dependent variables that is the number of followers, for example. You go one step, you have the scatter plot, and right here you are playing with two independent variables. For example, life expectancy and income per person. Yeah, and each one of them is a country. Okay? So you are playing with two independent variables. You cannot use the first example for this one. And this goes on. A pie chart, it must be our one single dimension. You cannot have right here 50%, 80%, 30%, it must sum 100%. And it's only a single dimension, and you have dependent variables. For example, I don't know, the brands that are selling the 100% in a certain market, for example. And the last one is a stack bar chart. This one you have independent variables, for example, the soccer teams, and then you have two accumulating quantitative dependent variables. For example, this one right here, it could be the perception in Twitter of a soccer team. People telling things about a soccer team. And you are dividing this conversation in negative and positive. So it's accumulating. So there are a lot of rules for that, and there are a lot of cheat sheets you can use. For example, this is a good one. If you want to compare over time, for example, many categories, you should use a line chart, so you don't have to think about it. There are a lot of cheat sheets on the internet. You can look around. This is one of the most accurate ones. I've selected another one, but it's the smallest cheat sheet. It's only points, lines, bars, and boxes, I think. Yeah. I think to visualize data, it's not just having a story to tell, but you need to have a background of math and statistics, even to understand what is an independent variable, what is a dependent variable, what is a continuous data type. But with this species, if you understand that, you can go ahead and create your own visualizations in a very easy way. In fact, this is a famous one. This is a Chernoff faces. The faces, the eyebrows, the shape of the face, the nose, the mouth, positioning and length of each element has a data type in the back. So I could see a face, and I could understand the data behind it. So this, for example, is not a usual chart type, but there are some rules to visualize this data, and it's a very fun and easy way to innovate in this field. You can, for example, create dashboards. In each module, you have a different chart type. You can do infographics where the chart types are inside the visualization. For example, a pie chart and a bar chart right here. You can innovate and create your own chart types. In this case, it's a mix of a bar chart and a pie chart. There are the colors in culture. You can see right here what it means in each culture, the color. And well, you can do whatever you want. In this case, for example, to visualize the components, the percentage of protein, carbs, and fat in a dishes, well, this photograph, play around with it and give proportion to that. So you can do whatever you want with that, but you need to understand the basics to do it. So we review the definition, the why, the process, and the basics, and now we get to the story. Once you understand the basic of data visualization, you can play around, create your own chart types, things like that, but you always need a story to tell. Even if a small one, it's different to communicate something or just see, I don't know, chart types and data, but not information for that. You have to have a great story. So there are a lot of ways to give a story in data visualization, but I've picked 3 main areas for that. This is the first one, presentation visualization. And in this case, it's all about, it's used for communication, not for exploration and things like that. And it doesn't support user input. It could be a video, a photo, and a static visualization. I bring you, this is a good example. It's from Bestiary. It's a Spanish company. They do beautiful infographics. They play around beautifully with data. In this case, this is a project for Barcelona in partnership with Telefónica, and they want to visualize the commuting phenomenon. The commuting phenomenon is based on the people moving from the place they live to the place they work, and to see what happens, I don't know, in the city, in this case, in the city of Barcelona, in the different districts, how the people move from the place they live to the place they work. Basically, they take the signal of each smartphone, and at night, they visualize they geolocalize the person at home, and then with the same ID of the phone, they detect during the day where they went. And well, this play, I don't know, it was like a couple of weeks, and they get only the persons with reiterative behavior. And once it was done, we can get the knowledge and we can visualize the data in a beautiful way. It's a shame that this visualization is not interactive. It's only a video, and it's also a book, but it's really awesome, all the knowledge they can get right here. And also what decisions Barcelona could make with this. For example, public transportation, giving services to places that maybe they don't have restaurants or things like that. This is another one. This is a strange one. This is one of the Twitter commercial videos they show to brands, so they can invest in their Twitter promotional formats. This is the repercussion of I think it's Walking Dead also, the TV show in this case. It was the show, it impacts a lot of people. They share the experience, and you see all this data coming around. But what happened in the commercials? In the commercials, Twitter has had a theory, in fact they prove it, that people that were looking in a commercial between programs, for example, in the case of Volvo, in fact, this is a real visualization, this is a real advertising. It impacts people, but people were quiet. They don't want to share a brand commercial for that. But if Volkswagen publish a promoted content, it will affect in Twitter too, because the people was watching the TV show, they was watching, then the commercials, then they look at Twitter. So they're going to get the commercial on the Twitter feed. So if Volkswagen did that with each of the commercials, the impact is exponential. So this is a real visualization. It's a commercial tool that is using Twitter. And this one right here is another kind of visualization. This is done by Outliers, and you can do anything with a map. It's like a video, but it's showing random content around Barcelona, geolocalized content. So when you think of presentation visualization, don't just think in videos, but also in web infographics that you can play around with it. Okay, the second one, interactive visualization. In this case, is used for Discover, and is also, it re-renders with the data input. We are moving from an author-driven visualization to a viewer-driven visualization. So right here, there are some guys that said, oh, hey, this is the story you need to view, to follow. And in the other case, it says, hey, this is a tool for you to explore. In fact, interactive narrative or interactive visualization leads to this. You want to just start in a point, and with your interactions, you get to different endings for that. Some examples. This is one from The Guardian, women's political rights around the world. So if you had, I don't know, for example, a presentation visualization right here, it would come up some data that would impact me. In this case, I can go play around with it. For example, in Spain, women received the right to vote in 1931. If I select that, I get more information, and I can also play around with it. So this is a viewer-driven visualization. Another example, this is a cool one. This was launched by Leeds and Manchester. They had a big problem with drunk drivers. People drank a lot and then drive. And you can see right here, there is an input where you can say, hey, I went out tonight and I drank, I don't know, 7 pints of beer. And all of the infographics just re-renders with that. And I can see I'm over the legal limits. There are some statistical values here of similar cases in other years. You can see the people killed with that. The penalties you have to pay for that. And then a simple map with places you can park to rest. So in this case, you have a story to follow, but you have some user inputs that re-renders the whole story. And this is the last one. This is also from Bestiary, and this was a tool for the South America citizen. You can see all these cities right here, and you can select. I don't know. It's crazy. It's like 500 indicators. Is really crazy. But I can select, for example, numbers of automobiles, and it re-renders right here. And I can compare the cities with each indicator. You can see City of Mexico is the second one in metropolitan surface of the city, and it's the first one in cars for that. And I can select this one, and you get the highlighted the whole path. So it's a beautiful tool to compare values. Okay, and we have the last one. Interactive storytelling. This is a new one. Is the mix of presentation and visualization and interactive visualization. It's based on a concept that is called the Martini Glass. The Martini Glass in data visualization and in storytelling, it has one part that is author-driven. You have to sit and just see the visualization that will give you a context. And after one point, it will leave you the tool you to explore for that. This is a common use for the most innovative visualization. I don't know if you know this one, evolution as a web. You have a beautiful transition right here. This is a very simple author-driven part, and then I can play around with it. I can play around with different timelines, and I can play around, for example, with different tools. In this case, I'm looking around the history of Firefox. A more complex example is this one. This one, it tells you the number of deaths by bombs in Pakistan over the years, and it gives you a first contextual part, like a storytelling, where you can read it and yeah, it will give you context. You can skip it if I click in the arrow, and then you have the tool. In this case, it goes further because it will show you the different years, and the data is going to fill in with with an animation of bombing. And you get also milestones in each year. It's pretty amazing. So the visualization is telling, in fact, the author or the team behind it is telling the story of this visualization, and it fast forward to the end right now, and once it's finished, it will leave you the data just to play around with it. So it finished, and then it will give me the control of the visualization for that. I can play around with it. I can select all the types of data. It's really amazing how it's done. So this is a very common, most common use for innovative data visualization, to tell a story and then give the control to the final user for that. And that was it. That was the storytelling part. So you need a story. There are many ways to tell the story, but these are, I think these are the biggest three groups of telling the story, but also you can innovate with that. So the last block of content, the tools. I made a simile with programming tools where you have this pyramid, where you have the flexibility of doing what you want with some technologies, and you have also the productivity of doing things with less effort. You can do less thing, but it's also less effort for that. So you can, play with assembly, code an application in C or C++, go with Python, and also go to Excel for that. So there are a lot of things you can do with Excel, but not as much as you can do it with Python. But the things you can do with Excel is very easy to do it, but in Python, it would give you a hard time for that. It happens the same with data visualization. So you have the bottom part right here, where you have SVG, Canvas, and WebGL. How many of you are technical profiles? Okay, 50%. The rest, various things. Graphic designers, yeah, okay, perfect, okay. I'm going to, after this slide, I'm going to give you a little introduction on SVG, D3, a little example of Dimple.js. I'm going to do a little demo with Tableau, so you can see the whole process for that. Well, SVG, Canvas, WebGL, D3 is a library, an API that works on top of SVG. So you can, in a I'm going to say an easy way, but it's not. But it's what you can do with D3, you cannot do it with SVG, but you can also control this with D3 in a very simple way. You can go higher, and this library right here, Dimple.js, is based on D3, and when you have a hard time doing some basic things in D3, you can do it with Dimple.js. And then you have Tableau. It's like Excel. It's a software to visualize data. In fact, to play around with data, if just the first stage when you want to find a story for that, you must take the first tool. It doesn't fit you. You can go down for that. But if you want to play around, feel comfortable of doing things that are more productive for that. Okay, so let's view some example of each one. In this case, this is SVG. It's a web standard. It's the same as HTML. It's a markup language. You can just include these codes inside an SVG tag, inside an HTML. So if you include circle and you're selecting right here the position inside this SVG, what you see right here, that is a canvas you can draw. The radius of the circle and the fill of that, the color, it will give you a circle. As simple as that. You can play rectangles and other figures. In fact, SVG has also things like path, where you have this strange syntax, but you can move and draw lines and complete figures and fill them with color and create things. Basically, you can draw, and also you have tags. For example, the G tag to group different elements, and you can play around with it. And you also, if you are creative, you can create very creative drawings. In this case, this guy drew all of the Batman symbols over the years in SVG, and in fact, it creates an animation for that. So this is SVG. This is drawn in a canvas, in an SVG tag, and it plays the animation just with this beautiful tag right here. So this is it. This is SVG. You can go as far as you can, and it will give you a hard time for some things. For others, it's very simple. But if you want to control not only the SVG, but to gain power controlling the DOM elements of a document, including SVG, and doing other stuff, you must go to one step higher, to D3. D3 is a JavaScript library. It was created to produce dynamic and interactive data visualization. It's not just a charting library. You can build chart with it, but if you only want to build chart, you must use a very easy library, for example, HighCharts. D3 is not a graphics layer. It doesn't have their own graph. It always plays with SVG and HTML elements. The elements in a web page, you just play around with it, as we're going to see right now. And it's not an SVG polyfill. It's not just to control SVG. I want to create a symbol. I want to a circle. I want to do it with D3. It will give you a hard time. Well, not very hard time, but much harder than do it in SV3. Or in fact, you can play with Raphael.js. It's an SVG library. A JavaScript library to play with SVG. So D3 is a visualization tool. It's a visualization tool. It has two parts. In fact, it's like an API. You call different methods. And you have the data part. D3 has a lot of power to process data. You can send an array of numbers, and you can process it. And it's also, you have the visualization part, visualization part to bind, to take element for the HTML and play around with it, change the color of the font or the feel of an object, things like that. And it also have different functions and methods where you just call a function and you don't play with SVG. It will create the SVG itself. So let's go into through some examples. I found this GitHub page. It's from a user. His nickname is Angelot, and right here, if you go to the main menu, it will give you a brief but very deep overview of D3. Is really awesome, and it gives you also an overview through SVG. So right here you have the SVG, and it also helps give you tools to play around, changing the code right here. So it's very fun to understand the basic concepts. If you go to the binding API, the binding API is to create SVG elements and play around with it. So in D3 we have to create, in this case, create an SVG element. Is this one right here? It's a canvas when we can play around, and we use the append method to the SVG element to draw things. So I use append circle, and it will draw me this circle right here. In fact, I'm going to delete this one. Okay. So this is the code to draw a circle. You have the SVG. You can declare it right here, and you use append basically to draw things inside the SVG. You can also select elements like jQuery. In this case, I'm selecting this. I cannot do it with the microphone. Okay. Okay, so in this case, with D3 and the select method, I'm selecting this area right here. So I can just go ahead and play this one. Okay, so I'm selecting this leaf right here, and I'm selecting the H2 tag inside this div. So if I change this one, it would change, because with D3 I'm giving the background color for that. I'm also selecting the SVG inside the select tag. So we have the select tag. Sorry. Okay. The right. No, I'm going a step further. Oops, sorry. So we have only select the H2 and select the SVG inside this one, and just draw a rectangle. If I could. Well, I have to change the attributes for that. Well, so I'm drawing a rectangle. I can also select all of the elements with a tag, for example, H2. I'm selecting all of the H2 elements in this page, so you always change around. So with D3, I can select elements like jQuery. If we want to draw data visualization for that, there is an enter method where we have, for example, a array of data, in this case with 4 data types. And I can use the select method because I want to select this part right here, the right part, and it's called this one, enter right. So I have this one right here, and I'm selecting all of the div item elements inside this div. In fact, if I erase this one, you can see right here there is any elements, but I'm selecting them. What happened here? D3 will allow us to select elements that doesn't exist in the present. So if I create in the future a div class item element inside this div, it will get selected, just as simple as that. The enter method right here, I'm passing the data, this one right here. So the enter method, it will create as many items in HTML code as many items I have in the array of data. So with this method, I'm creating these items right here. And finally, with this, I'm giving a style for each one of those. I'm telling that the width is 20 pixels. I can change around with that. The margin between each one of them is 15 pixels. The color and float. And what happened with the height? If I change this one right here, and I say like 20 pixels, it will give the same height. So I want to be dynamic for that. So what I'm giving here, the D is for data, and I'm passing the data and return the data plus the pixels. So it's drawing right here 50 pixels for the first item, 100, 150, and 200 in each one for that. In fact, I can change this one and get 400. It doesn't work always this way because I have, for example, small values like this one. Is crazy. So we have to need a method to convert the values to pixel for that, as we're going to see in the next example. And for example, the exit method right here, it will select the items in a new data set that are not in the first one. For example, if I put here this one, it would not affect the exit method. I'm changing the background color to red. But in this case, it will affect because there are the two missing values right here. So it's another thing to play around. We can also play with transitions. For example, if we have a data set and we paint it this way, and then we add a new data set for that, we can use this one right here, transition, delay, and duration, to change between two data sets. For example, if I change this one, you get the transition. As simple as that. In fact, the binding API, you have to play around with it and change some concepts. But once you get it, it's very easy to play around with the DOM elements and creating new elements for data visualization with the binding API. And also you can use events, for example, click. If I click right here, it will change the things I'm telling right here, the background color and giving the text. I can change this here on mouse over, for example, and I'm passing around for that. So it's very easy to play around with it. So this is the binding API. Oops. This is the binding API. So you are playing with elements in a HTML document, mostly SVG and HTML tags. I'm playing around with visual styles for that. But D3 has also a non-binding API. For example, in this case, with this little code, we are drawing this bar graph. It's a very simple bar graph, but it's a bar graph. You cannot see here any circle, square, any declaration on SVG. It's inside the method that is inside the code. I'm going to explain just a little bit this one. And I'm not going to go further because of the time, and because I think to understand the non-binding API, you have to play around the binding API a lot. So in this case, we have an array of numbers. This one right here. In fact, this one, it doesn't matter. We have an array of numbers, and we are playing with a linear scale. What does this mean? It's a converting method between the values and the pixel values in a linear way. So we need to have a domain. The domain is basically the minimum and the maximum number for that. And this function right here, I'm going to show you. Okay, this number right here has two numbers, the min and the max, and it's getting this information from the data, from the array, 0 and 20. These are the min and the max numbers. So that's the domain. And we have the range. The range is the pixel numbers for that. So what I'm saying is 0 pixels, the 0 value must need 10 pixels for that. So if I draw right here the 0 value, it will give me 10 pixels. So it's very simple. If I put right here 0, it will get 0, 0 from 0. And 20, it will give me 10 pixels. So I'm not playing with SVG directly, but with these tools, it will generate, in fact, SVG and text and rectangles, just as we've seen before. So the non-binding API is a hard one. It doesn't have a very high learning curve at first, but when you go deeper, you can find things like this one, the Geo API. So in this case, this whole code, it will give you this map, and sometimes it's like magic. It's crazy. But once you get used to the syntaxes and the way D3 operates with the elements, it's very easy to play around with it in a certain way. You have to go slower. In the case of Dimple.js, this whole graph is drawn with this code right here. This graph, in fact, we have, for example, the axis, the legend. We have some beautiful animation. This one, all of that is done with this code right here. In fact, is with this code right here. So Dimple.js is on top of V3, and it will help you to play around with basic visualizations. It has some Okay. It has some bar graph, pie charts, and you just copy the code and play around. So it's a very easy visualization tool for starters. You cannot change much around that, but if it fits you, you could use it. Okay, and the last one, Tableau, as this on the top of the pyramid. Tableau is a very powerful tool for data visualization. What I'm showing right here is data from the, 20 years of Eurovision contest. So what I'm showing right here are the different countries, and if they vote to the final winner in each of the years. So you can see, for example, right here, that Italy always got it wrong. It never voted for the final winner. Yeah, it's cool. So if we want to, I'm going to show you just a little bit one simple exercise with Tableau. I'm going to get the data set of Eurovision. Is this one right here? So I have the Eurovision winners and the countries who vote. And this is the visualization you just saw. If I want to do this in a map, in the case of Tableau, I just erase these values right here. And what I need to do is just give latitude and longitude, and you get a map, as simple as that. And if I add, for example, the country voting, you have the dots. And I have calculated right here the number of votes of each country. I can just put it right here and say this will change by a size. And I'm going to put it a little higher. So that's it. 10 seconds, you have a map going on, and with the same data. You have also a lot of different chart types to play around. So Tableau is a really cool tool for understanding the data and play around with it. I've left you some, I'm going to change the mic. Some resources right here. These are alternatives to D3.js. Don't forget the first one. Protovis is the previous framework or version of D3. In Dimple.js, you have a lot of great tools. You can play around with it. And with Tableau, you have Raw, Chartio, Plotly, and so on. There are a lot of tools for that. And for this presentation, I've used a lot of resources, and I'm giving you some books. These 5 books that you should read. The first 2 I've mentioned in the presentation, and the last 2, they are awesome books. Maybe Visual Storytelling with D3 is a very technical book, but you should play around with it. If you had Kindle, you could just get the sample, and if it fits you, get it. And in the online, I'm giving you 3 courses of data visualization and D3. This one is the first that I think was a year and a half ago. I took this course, and it was amazing because it takes you from from the very basic concepts of design, and will lead you to programming with D3, the basics. Data visualization, another course, and front-end masters. This is a technical one. And these are more links you should check. Mike Bostock is the creator of D3, so it's very cool. Flowing data and visualizing data are two cool blogs to get info. And I hope you like it. Thank you so much. If you have any questions,